All right, guys, unfortunately we're not going to be able to do the lab hands-on in class today. So I wanted to kind of demo it for you and give you some data. We'll do one trial, and then if I have more time today, I'll try to get a second trial done for you. If not, just use trial one and then neglect anything like calculate the average or something like that. So we've already done the Avogadro's principle lab, where we collected gas just from the regular gas jet in the chemistry room. And we, determined that no matter what the gas, if you know the volume, the temperature, and the pressure, that the moles will be equal. So we're doing another application of the ideal gas law today. We're going to use just an aerosol duster. So this is the stuff you use to clean your keyboard with. So it's a compressed gas that's in here. You can hear it as a liquid because it's actually under enough pressure that it's liquefied. As it comes out, it's aerosolized, so it's turned into an aerosol. So what we want to do is get the initial mass of that and not play with it anymore. So 143.8 is our starting mass. So 143.8 grams is our starting mass for the can. I've got a trough sitting here. It's filled with water. I've got a graduated cylinder. So I'm just going to fill it, overflowing, and then I'm going to put my hand on it and tip it over and invert it into the trough. So the goal is not to get too many bubbles. You may be able to see some that are rising up to the top there, but we don't have any huge bubbles to worry about. So then we're going to take our aerosol can, put the little spray director back on it, and then it's just connected, nothing fancy, a pipette, some masking tape, and then this tube. So we're going to put the tube down into the water and into the graduated cylinder, so it's kind of pointing up. Now, if I push down the graduated cylinder, I'm going to choke the rubber tubing, and I don't want to do that because I want to give free rein for that gas to go into the graduated cylinder. So as I gently press it, you can see those gas bubbles, right, coming up into the graduated cylinder. And so I'm very gently pressing it, and the procedure says around 170 to 190. As far as volume goes, this is a 200 milliliter graduated cylinder. So we're just slowly going to do that. If we do it too quickly, it can blow it all out. We don't want to do that. All right, so we get it down to almost water level. Go a little bit further. So our goal is, if you've ever played with toys in the pool, I know you're big kids, but you probably still play. If you've ever taken a cup that was empty and you put it upside down and some water goes, and then you can kind of smoosh it up and down, and so it captures that air in there. That's kind of what we've done here. So if I lift up, right, my water level is actually higher than the water level that's in this trough. I want it to be equal because when I do that, I'm saying that the pressure inside this tube is equal to standard atmospheric pressure. And that's what we're measuring right here with our CBL, our Lab Pro. And so we'll read off the temperature and the atmospheric pressure in a moment. So I want to make sure that I'm not way up here because that pressure then is not going to be equal. And I also don't want to be way below the water level. So when I get it equal, I'm going to put my finger on it. So it's now equal with the water level. And I'm going to turn it up. So now I've just lost my gas. So reading off the volume is right here. All right, so we've got about 184 milliliters. So our volume of gas that we captured is 184 milliliters. And be careful when you're doing post-lab because if we're doing ideal gas law, we want to make sure that's in liters so that it matches with our R. So now we need to figure out how much of the gas was used to create that volume. So zero our balance, and now our mass is 143.3. So 143.3 grams. So you can see we added about half a gram of the gas to get that 184 milliliters. So room temperature right now is 21.2 degrees Celsius. Again, Celsius is not friendly with the ideal gas law. And then our pressure is 0.99 ATM. Okay, so I'm going to go ahead and get one more trial in if I can. And so our new starting mass is just going to be our ending mass for that one. All right, so I'm going to get this overflowing, put my hand over it, and get it back into the tub. All right, so a few more air bubbles on that one. So that's one of your sources of error. If some of the gas that's already in there did not come from our aerosol can, then we know that's a source of error. So our starting mass for this one is 143.3 grams. Now our air temp and our pressure will just be the same because I don't foresee that changing in the next couple minutes. All right, so I'm going to put my tube back on, put it into my graduated cylinder, and again just slowly release the gas in there. Getting close to water level, take it a little bit further so that when I take my tube out, I can make it be level with the water that's in the trough. All right, so I'm going to put my finger on it when it's level and then flip it up. All right, so this one is looking like 185 milliliters. 185. All right, so very similar to what we had before. So let's hope we had about half a gram. We'll see what it comes out to. So when I put this on the balance, it's zeroed. We get 142.7. 142.7. So we actually had 0.6 grams for that, and we actually got an extra milliliter out of it. So again, use the same air temperature, same air pressure. So now you're going to work with your partner, work through the post-lab together, help one another, and see what you get for the molar mass of the gas. That's our goal. And then I will tell you what gas is in here. It's listed. It's a fluorocarbon. And so I'll give you the chemical formula once you finished your post-lab.